Assalamualaikum and good day. My name is Nurdania binti Azaman with matric number AE10066. Today I will explain my part, which is activity 1, open loop position control. Firstly, this is the circuit diagram. Then we must simulate it into the MATLAB. Here I have simulated it into the MATLAB, and then we will input the value into each component. Then now we increase step by step value of input angle from 0 till 10 and set attenuator gain 0. Then observe the shaft motor position display and what happened to the system. Okay, we need to increase the input angle from 0 to 10. This is the input angle, so here is 0. Then attenuator gain is 0. Then we must increase it into 1. Then we run. And here is the input voltage and the output of shaft motor position. Then we increase it to 2. The input voltage is increased to 1.222. Then we increase it into 3. This is the output. Then we must increase the input angle to 10. Then we must observe the output of input voltage and the shaft motor position. After we done this step, we must do this step 5, which is increase step by step value of attenuator gain from 0 till 10 and set input angle 0. Then observe the shaft motor position display and what happened to the system. So here we must increase the attenuator gain by set input angle to 0. Okay, this attenuator gain, we must increase it into the 10, but input angle is 0. So we input it 0. Then the attenuator gain, we input it 0 until 10. So we start with 1. So we run. Then the input voltage and shaft motor position have same value, which is 0. Then we increase it into 2. Okay, it's the same. Okay, it's the same value. So we can conclude that if the input angle is 0, then the input voltage and shaft motor position will be 0. Next, we must do this step, which is set input angle 5, 10, 360, and plus for potentiometer clockwise, and for negative with anti-clockwise is. Okay, so firstly we input angle position with 5 and attenuator gain 1. 5 and 1. So we run. Okay, here is the value. Then when it comes to anti-clockwise, -5. Then we run. So the input voltage and shaft motor position value become negative. Okay. Then we must repeat it with the different value for 10 and 360 for both clockwise and anti-clockwise. Okay, here is the result of the open loop position control response for 5, 10 and 360 for both clockwise and anti-clockwise. Okay, that's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Noiman Mefarin and my metric number is DE200-116. Here I will explain about activity 3.3.2, closed loop position control. Okay, so this is the block diagram, and this is the block diagram that I make in MATLAB. Okay, so the instruction is check the block simulating by key input angle, one alternator gain value is 1. Okay, so this is my block diagram. Input angle, position sensor input, alternator gain, this is for electrical part, this is mechanical part, shaft motor position, input voltage and output voltage. Okay, so first is increase step by step value of input angle from 0 till 10 and set alternator gain 0. Observe the shaft motor position display and what happens to the system. Okay, so the instruction is input angle 0 value and alternator gain also 0. So then we run the system. So the result for shaft motor position is 0. Then we change to value 1. Alternator gain also 0. So the shaft motor position also 0. And we change to the value of 2. Alternator gain is 0. And we run the system. Change to 0. So we try to change to value of 10. Then we run the shaft motor position also 0. So the second instruction is increase step by step value of alternator gain from 0 till 10 and set input angle 0. So now input angle 0, alternator gain 1. Shaft motor position also 0. It's to value of 2. Okay, shaft motor position also 0. 10. Okay, so the alternator gain also 0. Shaft motor position also 0. So next is set input angle 5, 150, 360, positive and negative, positive for clockwise and negative for anti-clockwise, and fill in the result into table. So we set the input angle 5, alternator gain 1. Okay, so this is for value of 5 for input angle. This clockwise become positive, and we got shaft motor position is 3.927. Then we change this for 150, 150, and alternative gain is 5. dekat 138.5 for shaft contribution. Okay, this step will be repeat for 360, and for anti-clockwise we have to put the negative. Okay, that's all for me.